Hello, and welcome to another screencast. This screencast will cover Investigation 1 Levers from the FOSS Levers and Pulleys Science Kit. I'm Jose Rosa, Science Specialist at the Mason Pilot Elementary School in Roxbury. Now, I like to have some fun with these screencasts, so look at what's behind me. If you saw my last screencast, you might remember that I collect comic books and action figures. Also, you might notice that I changed something. Can you tell what it is? If you can't, you'll have another opportunity during my next screencast. But now, let's begin going over this investigation. During this investigation, students are introduced to the lever and they learn about effort and work. Let's go over the parts of a lever before continuing. The parts of the lever are the lever arm, the effort, the load, and the fulcrum. Students will also be manipulating materials to build lever systems and explore how the relationship among the locations of the effort, load, and fulcrum affects the amount of effort needed to lift the load. This leads to students exploring some real world tools and trying to identify what lever class each tool happens to be. Now, the tools that the students will be exploring, and they have to be supplied by you for the most part, are the broom, the nutcracker, scissors, bottle opener, pliers, tweezers, hammer, and the human arm. And before going over the investigation, let me go over some tips that might make it easier for you to teach this unit. Each investigation has its own duplication masters that students use to record data and write notes. FOSS also has half-page duplication masters with two masters per page. Now, the one on the screen right now is the full-page master, but the size with a half-page masters is perfect if you want to have students paste their pages in their notebooks, especially if you use the marble type notebooks. Personally, I prefer to use a hybrid note-taking system. I use a combination of duplication masters and a notebook. Students paste the half-size masters in their notebooks. Then they write notes on the blank pages. In addition, I use a simple format for notebook organization. Students start with a table of contents, they number their pages, and they have a word bank in the back of their notebooks. I also go over a rubric at the beginning of the school year with students. The scales, by the way, are not very accurate, so it's okay if the measurements are not constant among the different student groups. Also, make sure to remind students to set the scales to 0 prior to each investigation. It's important that you teach students how to read and use the scale correctly. Okay, now that that's out of the way, let's go over the materials you'll need for this investigation. You will need 2 spring scales with rubber bands, 2 loads with rubber bands, half-meter sticks, binder clips, dowels, and pencil cap erasers. You will also need duct tape and a heavy book to hold the dowel down to the table. Now, I find it useful to use Ziploc bags for students to store their materials. Everything fits nicely in a Ziploc bag except, of course, the dowel and the half-meter stick. Regarding your ELL students, I recommend that you pre-teach vocabulary to them ahead of time. Also, use images of the different materials when going over them with your students. This will not only help the ELL students, it will also help your special needs students. Now, during lesson 1, you will be demonstrating a real world lever, and you will have students explore that lever prior to them investigating the materials. The teacher guide suggests that you use a lever like the one shown in this picture. However, this requires that you get a 4x4 wooden beam and a 2x6 long beam. Not to mention, it might not be very safe for you unless you hold onto a chair while students lift you up. Now, personally, I prefer using nutcrackers and having students crack open different types of nuts. Of course, you have to be careful about peanut allergies if you do it this way. Now, once students explore the real world lever, introduce the terms lever and advantage to them. Again, try to pre-teach these terms to your ELL students. Show students how to set up the lever systems and have them explore the lever systems for 5 minutes. The second part of this lesson focuses on teaching students how to use the spring scales to measure effort. Again, remind students to set the scales to 0 before measuring. Now, the teacher guide specifies that you use an overhead projector along with a modified spring scale transparency copy. This is explained on page 12. This will also work with the document camera and projector. Now remember, students should be given time to practice measuring the effort needed to lift a load. Now let's look at some key vocabulary words. Main terms that students need to learn for this particular part are the lever, lever arm, fulcrum, load, effort, and newtons. Lastly, don't forget to read the selection called Simple Machines, which is found in the False Science Stories book. Now that we got through lesson 1, or part 1 as it's called on the teacher guide, let's go over parts 2 and 3. They are almost the same, except that for part 2, lever experiment A, students measure effort while leaving the load constant on one location. So the load stays at 10 centimeters from the fulcrum, and the scale starts at 2.5 centimeters from the fulcrum. Then it goes to 5 centimeters, then to 10, then to 15, then to 20, then to 25. Again, the load stays constantly at the 10 centimeter mark from the fulcrum. Now, as you might have guessed, in part 3, lever experiment B, students measure effort while leaving the scale constant on one location on the lever arm. For lever experiment B, students then move the load down the lever arm starting at 2.5 centimeters from the fulcrum, then they go to 5, then 10, then 15, and so on until they get to 25 centimeters from the fulcrum. Now, after students collect their data as they're working on their projects, they're writing their measurements in the duplication masters for lever experiments A and B. If you notice, there are 2 columns on the data table part of the duplication masters. Why do you think that is? If you look carefully, you'll notice that students will add 0.5 newtons to their initial measurement. The reason why they're adding 0.5 newtons is that the scales weigh 0.5 newtons, and the scale's own weight is adding to the overall force that the students are applying to the lever system. Now, let's look at some student work samples. Again, if you use the marble notebooks as journals, you can print the half-page duplication masters and have students glue them in their notebooks. Now, as you look at the student work, some final notes. The reading selection for part 2 is class 1 levers, and for part 3, it's the wheel and axle. There are a couple of nice assignments you could give for homework. One is Homeschool Connection, which is number 32 in your guide. And the second one is, after part 1, is response sheet levers, which is number 5 in your guide. These are good assessments to give students for homework. The science department also has outdoor levers and pulleys guides. You could talk to them about getting them. And well, that's it. That's all the time we have for today. Something I forgot to mention is that force is measured in newtons. And if you look at the spring scale, the right side is for effort or force, and the left side is for mass. Okay, that's it for this screenshot. Until next time, may the force be with you.